Hello friends and welcome to the Automation Nation YouTube channel. In this video, I'll be using Notebook LM once again, but today's interactive mode, which is currently in beta, to create an AI-generated podcast featuring two virtual hosts. But here is the exciting part. I'll be able to join their conversation and ask my own questions. So today we're going to focus on chapter number 6 of the ISTQB Test Automation Engineer syllabus. It is called Test Automation Reporting and Metrics. So I have already uploaded the information from the syllabus to Notebook LM. As you can see, you can just click to add source. And so for now, I'll be able to interact with AI and explore key concepts based on the provided materials. So I will be able to join their podcasts. So whether you're preparing for the ISTQB certifications or simply looking to deepen your knowledge of tested automation and wondering how you can use AI in your day-to-day activities, just make sure to subscribe and stay tuned for insightful discussions. Let's get started.
Right. Management wants trends.
Such as how many test cases were added.
Changes in the pass-fail ratio.
And operational stakeholders, those are product.
Yeah.
Could you please explain me more about management stakeholders? I didn't get it.
Sure, let's circle back to those management stakeholders.
It's a really important distinction to make.
These are the people who are making decisions.
About the project's direction.
Absolutely.
The syllabus says they're interested in visual summaries.
So they can quickly grasp the overall status.
Exactly.
They want to see those colorful charts.
And traffic light icons.
Anything that gives them a high-level overview.
So they can make informed decisions.
So for these stakeholders,
focus on trends and key performance indicators.
KPIs, like defect clusters or set performance.
Exactly, the big picture stuff.
Anything they can use to assess progress.
And identify potential risks.
Hopefully that clarified.
Yep, go on.
Yeah, it definitely clarifies, but I wanted to ask additional question about creation of dashboards.
I'm so glad we could clarify.
All right, let's dive deeper.
According to the syllabus, dashboards are key.
Modern reporting tools offer so many options.
Colorful charts, detailed logs, automated analysis.
Tools aggregate data.
From pipeline execution logs.
Project management tools.
And code repository.
The visualization helps stakeholders see trends.
Defect clusters, SCUT performance degradation.
And reliability of builds.
Dashboards support data aggregation.
Okay, but how do you...
Okay, let's pause, and as you can see, friends, you can play by yourself with this really useful and cool tool and discuss whatever you want with it.
Alright friends, since we have reviewed the interactive mode, now let's dive deep into each and every section of chapter number 6, or collection, analysis and reporting of test automation data. So first of all, we've already heard that the data can be collected from various sources. So since the system undertakes test logs, web, mobile UI, API, applications, web service, database service. Also, our tough logs to provide an audit trail, build logs, deployment logs, and production logs, as well as performance monitoring, performance efficiency test logs in a performance test environment, for example, load, stress, and spike testing. Also, we can collect some information from the screenshots and screen recordings, so native to the automation tool or third party. So since TAS has automated software at its core, the automated testware can be enhanced to record information about its use. Testware enhancements made to the underlying testware can be used by all the high-level automated test scripts. For example, enhancing the underlying testware to record the start and end time of test execution may well apply to all tests. So let's talk about the features of test automation that support measurement and test report generation. So the scripting languages of many test tools support measurement and reporting through facilities that can be used to record and log information before, during, and after test execution. So it's really important that we can gather information before, during, and after test execution of individual tests and entire test suites. So test reporting on each of a series of test runs needs to have an analysis feature to consider the test results of the previous test runs, so it can highlight trends such as change in test success rate. For example, it was green and now it's red, it failed. Test automation typically requires automation both for the test execution and test verification. The latter being achieved by comparing specific elements of the actual results with the expected results. This comparison is best done by the test tool using assertions. So the level of information that is reported as a result of this comparison must be considered. In this, it is important that the test status can be determined correctly. For example, passed or failed. So there won't be any false positive or false negative. In the case of failed status, more information about the cause of the failure will be required. For example, screenshots. So differences between actual results and expected results of a test are not always clear, and tool support can help greatly in defining comparisons that ignore differences that are expected. For example, such as time and dates, while highlighting the any unexpected differences. Test login. Moving on to test login. Test logs are a source that is frequently used to analyze potential defects within the test automation system and system under test. In the following section are examples of test login categorized by task and SAT. So task login, the context determines whether the TAF of the test execution is responsible for login information that should include the following. Which test case under execution right now. So also the status of this test execution. While failures can easily be identified in test logs, the test automation framework should also have information and should report via a dashboard. So the test execution status can be either passed or failed or a task failure. So status can sometimes be inconclusive, and it is important for organization to define clear and consistent definitions of them. So task failure is applied to situations where the defect is not in system under test. So low-level details of the test log. Log in significant test steps, including timing information. So we are logging steps and timing. Dynamic information, memory leaks that the test case was able to identify with the help of third-party tools. Actual results and failures should be logged with the test suite that was executed when the failure was detected. So in the case of reliability testing or stress testing, where numerous test cycles are performed, a counter should be logged to easily determine how many times test cases have been executed. When test case has random elements, the random number choices should be logged. So we need to see what was the random parameter or random test steps in state transition testing. All actions that a test case performs should be logged in such a way that test logs or parts of it can be played back to rerun test with the same test steps and the same timing. This is useful to reproduce and identify failure and to capture additional information. The test case action information can also be logged by the system under test for use when reproducing customer identified failures. If a customer runs a test suite, the test log information is captured and can be replayed by the development team when troubleshooting a defect. Screenshots. Screenshots are also saved during test execution for further use during root cause analysis. And whatever test case initiates a failure, task should make sure that all information needed to analyze the defect is available and it is stored, as well as any information regarding the continuation of testing if applicable. So the task should save any associated crash dumps and stack traces, also any test logs which can be overwritten. Cyclic buffers are often used for test logs on the system under test. Should be stored where they will be available for later analysis. And also feel free to use the color. Use of color can help to distinguish between different types of test log information. For example, defects in red and progress information is green. Moving on, let's talk about system under test login. Let's ask summarize, and we will use this information and compare, just to compare, to check if it's actual. So login is valuable tool. It includes defect information, configuration login, searchability, synchronization, and correlation trace ID. Let's compare. So correlation of the test automation results with system under test logs helps to identify root cause of defects in system under test. When a defect is identified, it is necessary all necessary information needs to be analyzed. So the defects should be logged, including date, time, steps, source location of the defect, and error messages. At the startup of system, configuration information. So configuration login is really necessary. At system startup, local configurations such as software versions, system under test configuration, operating system. So we're talking here about all the configuration information. The next one is using test automation. System under test logs can be easily searchable. A failure identified in the test log by the task should be easily identified by the test log of the system under test, and vice versa. So, with or without additional tools, synchronizing various test logs with timestamp facilitates correlation. So we are talking here about correlation of what occurred when a failure is reported. And they also mentioned trace ID. If the system under test has audit logs for user interactions, each interaction should have a unique ID. Moving on to integration with other third-party tools. When information from the execution of automated test cases is used in other tools for tracking and reporting, it is possible to provide the information in a format that is suitable for third-party tools. It is often achieved through existing test tool functionality, for example, report formats or for test reporting, or by creating customized reporting. So just for the to output in a format consistent with other software. The next one is visualization of test results. Test results can be more visible using charts. Consider using colored icons such as traffic lights to indicate the overall status of the test execution, test automation, so that decisions can be made based on reporting information. Management is particularly interested in visual summaries to see just test results, which aids in decision making. If more information is needed, they can still drill down into the details. So the next part of our chapter is to analyze data from test automation solution to understand test results. After test execution, it's important to analyze test results to identify possible failures, both in system under test, if there is some bugs in our application, or test automation solution. For such an analysis, the data collected from the test automation solution is primary, and the data collected from system under test is secondary. Analyze test environment data to support sizing of test automation. For example, in the cloud, clusters and resources, the amount of CPU or RAM required, single versus multi-browser, cross-browser test execution. Also, we need to compare test results of previous test executions and determine how to use web logs to monitor software usage. Test execution failures need to be analyzed, and there are potential issues. So what about the issues? Check if the same failure happened in the previous test execution. This might be a known defect. So the test automation solution can be built to log historical test results of the test cases, thus further helping the analysis. If the test defect is not known, identify the test case and what it is testing. The test can be self-explanatory, or test case can be identified by the test management system based on its ID, logged in the execution, and find in which exact test step, failure happened. So we're using task logs for it. Analyze the test log information about the state of the system under test and whether it matches the expected results using screenshots, API and network logs, or any log that shows the state of the system under test. If the state of the system under test is not what is expected, log a defect in defect management system, such as, for example, Jira or anything that you're using in your project. When there is failure, it is possible for the actual result and the expected result of the system under test to match. In these cases, most likely test automation solution might contain some defect which needs to be fixed, or an invisible mismatch is present, something that user cannot see, but all the same the results inside our assertion are not equal. Another situation when that can occur is if the test environment is not available during test run or only partially available. In this case, all test cases can fail, either with the same defect or if parts of the system are down with seemingly real failures. So identify the root cause of such defects. The system under test logs can be analyzed, which will show if there are any test environment outages at the time of the test run. So if the system under test implements audit logs for user interactions, it helps to analyze test results. There is usually a unique ID added to the interaction with the same ID for each subsequent call and integration of the system bits. In this way, knowing the unique ID of request or interaction can be observed as traced and traced back. The unique ID, usually called correlation ID or trace ID. This can be logged by the test automation solution to help analyze test results. So the next part is how to explain test progress report, how it is constructed and published. Test logs give detailed information about the test steps, actions to take, and expected responses of test case and test suite. However, test logs alone cannot provide a good overview of the overall test results. For this, it is necessary to have the reporting functionality. After the execution of a test suite, a concise test progress report must be created and published. A report generator can be used for this. So, content of test report. Test progress report must contain test results, system under test information, documentation of test environment in which tests were run in a format appropriate for each of the stakeholders. It is necessary to know which test failed and the reasons of failure. To make troubleshooting easier, important to know execution history and who reported it. Generally, the person who created or last updated it. The person responsible needs to investigate the cause of failure and report defects and follow up on the fix to the defect and test that the fix has been correctly implemented. So we are making sure that the fix actually works correctly as we are expecting. Test reporting is also used to diagnose any failures of the tough components. Publishing the test reports. So the next part is test report should be published to all relevant stakeholders. It can be uploaded on the website, on the cloud, or on premises, sent by mailing, or uploaded to another tool such as test management tool, some Teams, Jira, I don't know what you're using in your project, but this helps to ensure that reports will be reviewed and analyzed if individuals are subscribed to receive them by email or through chat messages posted via chatbot. An option is to identify problematic parts of system under test and keep a history of test reports so that statistics about test cases or test suites with frequent regressions can be gathered for trend analysis. We can analyze our trends also in our built-in tool. For example, it might be Sorry Cypress logs, or it can be some Playwright reports gathered on your CI/CD tool, but we need to have an opportunity to keep a history of our test reports. And talking about stakeholders, to whom we report. Management stakeholders, they are solution or enterprise architect, project or delivery manager, program manager, test manager, or test director. Operational stakeholders, they are typically product owner or product manager, business representative, or business analyst. And talking about technical stakeholders, it's team leader, scrum master, web administrator, database developer, test leader, test automation engineer, tester, or developer. So test reports may vary in content of detail depending on the recipients, while technical stakeholders may be more interested in lower level details. Management will focus on trends and how many test cases were added since the last test run, changes in pass-fail ratio, and reliability of a system of tasks and system under test. So reliability of our test automation solution and our application. Operational stakeholders usually put more emphasis on product use related metrics. So creation of dashboards may be quite useful. Modern reporting tools provide several reporting options through dashboards, colorful charts, detailed logs, some collections and also automated test log analysis. Therefore, there are many available tools in the market to choose from. These tools support data aggregation from sources such as pipeline execution test logs, project management tools, and code repositories. The visualization of data provided by these tools helps stakeholders to see the trends and make decisions accordingly. These trends can include defect clusters, increase, decrease, or defect propagation to certain test environments, system under test performance degradation, and reliability of builds. And the last one, artificial intelligence and machine learning, also can be widely used for our test logs. Some test automation tools include or are based on machine learning algorithms. Automated analysis of large amount of data in test logs helps the test automation engineer reduce time spent finding broken locators, analyzing the reason of test failures, and grouping common defects for test reporting. That's it. Thank you for being with me.